Now, here's what we're going to do. We're going to do exactly what we've done every other time. Now, see the way the question looks very complicated. There's a lot of letters where there's usually numbers, correct? That's the only difference. We treat everything exactly the same. So we start off with our four circles, our before collision and after collision, okay? And we just run through our motions, or we run through the game plan, no matter what. 4M, speed U. Oh, and that's actually a mass 2M. And 2M is actually going 0. How do we know that? Stationary sphere. The coefficient of restitution is E. Happy days. Now, after the collision, we're just going to do what we always do. A and B. Okay, for you guys? And now I have this information gathered, and it's just a matter of me using this information. It's a matter of me using this information and trying to put it into the equation. Now I'm going to start with PCM. M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. All right, let's do it. All right. First things first, we're going to do 4M times what? 4M times U. 2M times 0. 4M times, and then 2M times B. And then we're going to divide everything by M. And what I should end up with is 4U equals 4A plus 2B. There's some attempt marks right there. Haven't done anything remotely difficult yet. Right, now we're going to go for NEL. So what do we think about NEL? What's the formula again? V1 minus V2 equals U1. Okay. Once again, we have our routine. We're going to have to make a simultaneous equation out of this somehow. You ready? Let's do it. Multiply, so not multiply, just put them in. A minus B equals what? Minus E into U minus 0. Is everybody happy that A minus B is minus EU? Right, we pause it. All right, guys. So, what one of my good students said is that we divide by 2. So we divide the red equation by 2 and we get a 2A plus B equals 2U. I do have some good ones in here now. Now, what happens when you add downwards? What do you get? Anybody? 3A equals what? 2U minus EU. Now, what we're looking to do here is we're trying to make sure, see this part here in green? See that part in green? That's actually A. We're trying to make our A turn into the A that they have. So what do you think I should do? Factorize out U and divide by 3. And not the A, just the 3. And we now have exactly what they asked us to prove. Now, you could sub it back in. But I actually find subbing it back in is harder than redoing the equation. So I'll explain what I mean by that. So I'm just going to change sides on this one. So I'm just going to go back to the beginning. Okay. I'm going to grab the A minus B. I'm going to grab the A minus B equals EU. Okay. And you know what I'm going to do? I'm just going to solve it again. Except this time I'm getting rid of the A's. Is that all right? So what should I do with the blue equation to get rid of the A's? Any idea? The blue equation. Multiply by minus 4. What happens if I multiply that by minus 4? Minus 4A plus equals 4 EU. You all good? Okay. Now what? Add downwards, and what do we get? 6B equals 4U minus, plus 4EU. Okay. What happens if we divide both sides by 3? Or by 2, I mean. Equals plus 2 EU. Factorize out the 2U. and we get 1 plus e, and then put the 3 underneath, and we see that our answer is actually the same as theirs. So you can see the routine is exactly the same, isn't it? It's just that there's letters. Now, this is where it gets tricky. It wants the loss in kinetic energy. The loss in kinetic energy, right? So this is going to be fun. All right. So what we're going to have to do is the kinetic energy before the collision. So we're going to do kinetic energy before collision minus kinetic energy after the collision, right? Our only problem is there's no numbers. It's all letters, right? So that's our main problem right now. Okay. So we're going to set up two different sections, okay? We're going to do KE before and KE after. Now, KE before is easy. What's the only particle that's moving? The 4m is the only one that's moving, and the other one's not moving whatsoever, right? So it's a half mv squared for kinetic energy. So it's going to be a half 4m, sorry, a half 4m times what? And what's v squared? It's traveling at speed u, isn't it? So it's going to be u squared. And is everybody just happy that the answer to the kinetic energy before is 2mu squared? Why didn't we add the other particle onto it? It wasn't moving, it was stationary, so it had no energy. Now, the next one's tricky because both particles are actually moving. Now, a half 4m. What speed is it moving? A. So is everybody happy we square A? So what happens when we square A? U squared on the bottom, 9. And what happens when we square 2 minus E by another 2 minus E? Try and take a shortcut here just to save time. 4 minus 4E minus 2E minus another 2E, and then plus E squared. Is that okay with you guys? Now, plus what? A half. What's the mass of the second particle? 2m, and it's traveling at speed b. So we got to do a half 2m, and now we're going to have to square out b, aren't we? So what happens when we square out b? 2u multiplied by another 2u, 4u squared, yeah. 3 multiplied by 3, 9 on the bottom. Now I'm going to have to do 1 plus e by another 1 plus e. So what's 1 plus e multiplied by another 1 plus e? Yeah, it's the 1. Yep, I'll just have it the other way around, but it's exactly the same answer. All right. Now, at this stage, I'm going to look back at the answer again and figure out what way does it want me to deliver it. It wants me to deliver it in this form here. Yeah, a common denominator of 3 somehow, and everything just melds together. All right. So here's what I'm thinking. Right, here's what we're thinking. So I'm going to have to get this. See this blue one? I'm going to get that blue one, and I'm going to take away this green one. And it's not nice looking, is it? No, it's not. And we're just going to have to deal. Okay, you ready? Okay, here's how we're going to deal. First of all, a half of 2m, just m. Okay, so we're just going to get rid of that outright, all right? And then a half of 4m, 2m, all right? That's one fraction down, ready? Now let's multiply in. Would you all agree that that's 2mu squared? 2m by u squared? And then we're going to multiply that into all of these ones. So what's 2mu squared times 4? amu all over. And then what's the next one? 8mu squared e, ouch. And the next one after that? 4mu squared e squared. Say that 3 times fast. Now, What do we divide it all by? What's on the bottom? 9. I'm still working on the kinetic energy after the collision. Everybody on board with that? Still working on the kinetic energy after the collision. What about this side here? M by 4u squared is 4. Multiplied in 4 mu squared, yeah. Then next part. Lads, I made a mistake here. 2mu squared times e squared is not 4mu squared. It's actually 2mu squared. So big thank you to A in the corner there, sorting me out. Good man. Okay, feel good? It was a 2, not a 4. I'm glad somebody found it. Okay. Now, what happens when you multiply by e? 4mu squared times e. 8mu squared e. And then 4mu squared times e squared. Sorry, running out of board space here. 4mu squared e squared all over 9. Now we're fortunate that they have the same common denominator, don't they? So what can we do here then? Let's look at them. What's 8 plus 4? 12mu squared, yeah. 8 take away 8. All right, that's a lucky break for us, isn't it? One of them's gone, aren't they? And then what about the next one? 6. What's it? Mu squared and. Now, is everybody happy? That's the kinetic energy after the collision, right? And we're going to have to take this away from the kinetic energy before the collision, which we all agreed was this one here, 2mu squared. Whoa, 12 minutes at this. That's not good. All right, so that's 2mu squared. I'm going to give a common denominator of what? Going to give a common denominator of 9, right? So I'm going to turn that into a 18. Now, remember, it's a double negative. So it's going to be 18 take away 12, which is 6mu squared, yeah? And then minus 6mu squared e squared over 9. Okay. Common factor of 3 top and bottom. So what can I do there? So turn into 2mu squared minus 2mu squared e squared all over 3. Factorize out 1. What can I factorize out about is? 1 minus all over. And then now and only now I just have a quick peek up. Is it what I was asked for? Bam. Here you go. It's the same thing.